by the way, my name is Emily Saldanaha. I'll be leading the session today. I'm a data scientist here at the lab where I work on kind of a range of machine learning applications, including natural language processing and material science applications. It worked a minute ago. Cool. All right, so we're just kicking off kind of thinking about how we can use these tools for science applications. I thought this was kind of an interesting metaphor for the way large language models work. So a jazz musician doesn't memorize every possible melody. Instead, they internalize patterns, relationships, and structures that let them generate novel but coherent musical phrases in real time. LLMs do something similar with language and concepts. They've absorbed the deep patterns of human meaning making and can riff on them endlessly. So this is kind of quite different from how traditional machine learning works. It can be very powerful. That the types of patterns that these models have learned from the huge amount of data they've been trained on means they can tackle kind of lots of tasks out of the box without needing fine tuning. But there's also a lot of limitations to this approach, and it can be kind of challenging to see how to apply them and get them to work properly for scientific context. So this is something kind of to think about from a high level perspective, is how you can use this kind of AI approach in scientific applications. And then kind of digging more into the weeds of it, there's a lot of ways that we can use these to develop kind of pipelines for science. I'm sure a lot of people at this point are familiar with working with like the ChatGPT interface, doing kind of just chats with these LLMs and seeing how they respond. When we're thinking about really customizing these tools for scientific applications, we can really get a lot more into the weeds with it in terms of customization. So how can we modify our prompts? How can we give these agents and LLMs the information they need to do the tasks that may be useful for us? And then there's also questions of how we want to interface with these tools. So there's the ones that are proprietary, available online, like ChatGPT. There's also open source models that you can run directly on your own computer. And that can have some benefits in terms of your ability to control your information that you're sharing, as well as the kind of cost of using it. But in terms of kind of getting that top of the line, like state of the art performance, usually it's some of these proprietary models that tend to do the best. So there are trade-offs there. And we'll dig into some of these practical questions, especially in the afternoon sessions. And then before we go into a summary of the agenda for today, I just wanted to share a few kind of good starting points for where you might be able to learn about the types of models that are available and how you can use them in your own projects. So there's a few links here, which I'll go ahead and share in the Discord once I'm able to. So just gonna highlight them there. And then to kind of start kicking off the agenda for today, we've got a lot of interesting talks lined up this morning. So first we'll hear kind of more of a overview. Let us start diving into what is this LLMs topic? What is AI? How do LLMs fit in? Then we'll hear a talk on using retrieval augmented generation to give LLMs kind of more background information, more context to work with when they're trying to answer your scientific questions. And then finally, a talk on an application of LLMs to a scientific application in chemistry through the Cactus tool.